So, good afternoon, everybody. Thank you very much for coming. I know it's hard, especially on the last day after lunch. I hope to keep you awake because I have a lot of cool demos to show. And my name is Edson Yanaga. I'm a Director of Developer Experience at Red Hat. My Twitter handle is @Yanaga. And today I'm going to talk about advanced pipelines for hypothesis-driven development, and maybe some other advanced pipelines that can be used for hypothesis-driven development or for traditional pipelines too. I'm also a Java champion, a Microsoft MVP, and I work for Red Hat, which I believe is a very cool combination, but you don't have to trust me, okay? And we are going to start the discussion with DevOps, and of course, DevOps has been, this term has been coined in 2009, and many things have evolved in the past. So in the beginning, we were trying to automate our builds manually. We used to create our own bash scripts for our deployment pipelines. Then later, we created some tools, and most of the people these days are using continuous delivery pipelines to be trying to deploy their software faster and safely into production. But the main discussion behind DevOps, microservices, and continuous delivery until now has been trying to avoid the bugs that we have into production. Because every time we deploy things into production, we screw the things. So when we're talking about continuous delivery and DevOps, basically, we're trying to reduce what technically in the DevOps world we call batch size. So I used to be a consultant before joining Red Hat. And the number one excuse that everybody gave me for not deploying faster into production was, I don't deploy faster because I break things and things go bad into production. So the solution that I've been giving to this problem is that, well, you need to reduce your lead time. And to reduce your lead time for developers, the easiest way for you to be able to reduce your lead time is to reduce your batch size. And technically, it is the amount of changes that you have between each one of your software releases. So I'd like to establish a very simplistic correlation to you right now. In the DevOps world, we say that whenever I break things into production, these bugs are usually caused by changes in 3 different areas. You can have changes in your behavior, which means you changed code. You can have changes in your data state, which means you change your data. And you can also have changes in your environment, which usually means that you changed your infrastructure or your configuration over your infrastructure. Okay? So bugs in production, when you deploy software, are caused by changes in these 3 different areas. To oversimplify that and to be able to establish a simple correlation, I'll say that bugs in production are caused mainly because of changes in your code. So the human way of trying to solve that is that, well, maybe if I'm releasing every week, now I need 2 weeks because I'll have more time for testing. But people don't realize that the more time you have for testing, the more time you have for coding too. So you're just increasing the batch size that we have between each one of your releases. And the DevOps way, the economical way of trying to solve this problem is trying to reduce the batch size of your releases. And if you reduce your batch size, you're going to reduce your lead time and your cycle time too, which are other 2 important metrics in the DevOps world. So if you can keep reducing your batch size until you get the ideal size of 1 commit, 1 deployment, we as humans, we can clearly establish this correlation. I'm doing this, I'm getting this result into production. Okay? So if I just change this code and I have a bug, well, the cause of the bug very likely is on that 15 lines of code that I just committed. And this has been the discussion in the past almost 10 years, trying to reduce what we call the batch size to improve our feedback loop regarding bugs in production. Okay? So until now, most of the companies, they are trying to reach this level of continuous delivery to reduce the risk of deploying new versions of software into production. So this is an advanced talk. So to be able to discuss the 3rd step, you need to have a fully automated software deployment pipeline. You need to have a fully established monitoring platform. So releasing software into production is not an issue anymore. You can do that fast. You can do that in a safer way. But now that we solved this problem, we can discuss more advanced pipelines. And traditional pipelines, Usually, you're developing your software, you know the roadmap, you know the features that you want to implement right now. You just do a commit over another commit, and you expect these commits to be deployed into production successfully and in a successive way. Sorry. I'm not a native English speaker. I don't know if I told you that before. I'm a Brazilian Japanese, and many people are curious about that. But yes, we have a lot of Japanese in the south of Brazil. So traditional deployments, you deploy version 1, then you deploy version 2, version 3, and you're always expecting that version 2 is better than version 1, and version 3 is better than version 2, and so it goes on. But when we try to discuss hypothesis-driven development, we need to think in a different way. So think about if we're developing software in a traditional way, we're very likely developing software just like in a restaurant. You have a full buffet. You just releasing new features in the hope that all of the features will be consumed equally and all of them will have the same impact into the business value. So you just cook everything all the time. You just keep... then later into production, you just cook it all. Oh, this food, people are eating more, just like you had in the buffet at the lunch. But then people on the kitchen needs to produce more of that feature just to replace the one that is empty. So we're just giving equal emphasis on all of the features that they're developing, even though we don't know if every feature is going to be consumed on the same way. So I guess it happened here too. Sometimes you have more vegetarians, or sometimes you have more meat lovers on the attendees. So you have different variations on how people consume the food. And basically, if we're just cooking food that is not being consumed, we're wasting precious resources. And as software, we're wasting many developer hours and brain power trying to produce features that are not useful into production. And when we're talking about hypothesis-driven development, instead of trying to produce we're just releasing a new version and deploying everything into production, with hypothesis-driven development is much like we're trying to create small plates of each one of the features that we want so we can test them into production. And maybe, well, people are eating more of this dish. Maybe I need to produce more on this. I'll put more man-hours behind this feature so I'll get better results. So that's the analogy that I have to do with food and software. And it's appropriate because we just had a food buffet here. So with hypothesis-driven development, I have version 1.0, and maybe the business guys or even the developer people, I don't know how I will implement this feature, right? I don't know if this feature will perform better this way or the other way, so you have this doubt in your mind. So you have two different ways of implementing a certain feature, or you have two different features that you might want to test, two different hypotheses that you want to test in production. So maybe A and B, and after running both in production for a certain time, you just evaluate and assess them and say, well, version B is better than A. Hypothesis B is better in production than hypothesis A. And most of the examples that we have on the internet talking about how do you do that, people say well, maybe the color of the web page, positioning of the bottom, and everything else, which are typical use cases if you're testing user interfaces. But most of us enterprise developers are back-end developers. So when we're talking about hypothesis A or hypothesis B, usually we're talking about some certain business process or business flows or different algorithms that we can implement on the back end. And so some people use that for, I want to implement a new recommendation engine so I can switch backends on the fly. That's two different hypotheses that I can implement. Maybe yes, I can have two different workflows for the process that the user is interacting with. I can have two separate backends for that too. Maybe I want to try a new indexing engine. But I don't want the previous one to stop working because that is the safe one. I don't know if the new one will perform as good as the previous one. So you can also test different hypotheses. And the first approach for creating pipelines with hypothesis-driven development is feature branching. So most of us developers are used to this approach. Since now we are very used to like using GitHub. I create different branches. I create pull requests. Then traditionally, it has been first pipelines. I've seen the people doing that. It's like 6, 7 years old. People decide, whoa, we have a continuous integration engine. I have the trunk. Well, at the time was Subversion. People were using trunk. Now everybody's using Git, and we have a master. So maybe I can just create another pipeline, point to another branch of my Git repo, and that will lead to a separate repository. Okay? And then maybe into production, we need a way to switch between the traffic between just trunk or master and the other feature branch that I'm just developing. And this is the basis of what we've been calling so far A/B testing. You have two different hypotheses into production. I want to test A and B. Which one is better? But of course, you can't test that kind of hypothesis without monitoring your platform. So I won't be able to have time today to set up a monitoring platform. But of course, if you're trying to test hypotheses, each one of these algorithms, each one of these implementations into productions need to populate some kind of metrics into your monitoring platform to know which one is performing better. And you need to monitor these metrics for a certain amount of time. And you need to guarantee that each one of the other variables in your system are the same. Like if you have a time-sensitive implementation, it's not enough for you to test, well, let's test this implementation today, and let's test version B tomorrow if your traffic depends on, well, Friday is a quiet day. Okay? So you need to monitor that for a certain amount of time to have meaningful comparisons. But it really depends on your use case. I saw a taxi company in Brazil, for example. They used to perform A/B testing and had a monitoring platform. They've been gathering statistics for a long time. So whenever they try they want to try a new hypothesis, they test the baseline. Well, how our platform performed on this day, on last year, on these exactly same hours, and if the numbers are different, well, was it raining? Okay, did we have any particular event? Did we have a strike? So they can have meaningful comparisons. And all of these you have to keep in your mind when trying to establish comparisons between hypotheses. But again, it really depends on your use case. I won't dig into the monitoring part, but I'll dig into how can you switch and flip your implementations for A/B testing. So first approach for if you have feature branches. First approach for doing this kind of A/B testing is using smart routing. So if you want to perform a smart routing, you need a smart router. So you have a proxy in front of that, and you can dynamically change the amount of requests that goes from one deployment to the other deployment. And with smart routers, some people say that you can use smart A/B testing with just infrastructure. I don't have a clear term for that. I call that dumb routing, because if you can just split 50-50%, okay, it's better than nothing. But usually, smart routing is much better when you can target a certain group of users from your platform to that new deployment, right? Because when you're testing hypotheses, usually, if you're mature enough, you don't want to test the whole platform at the same time. Maybe I want to improve my metrics for this specific type of users. Maybe I know that my platform sells very well for teenagers ranging in the age from 15 to 25. I don't know if 25 are teenagers, but sometimes you have some cases about that. But maybe your platform is not performing well enough for women on the same range. So maybe you want to test your new version just for women to see if your platform performs better. So this is what I call real smart routing. And if you want to perform smart routing on this level, you need a layer 7. Like you need to tweak the business process of your application to perform this kind of meaningful router. Okay. And the most popular smart router that they have today is Zoo, which was created by Netflix. They just recently released Zoo 2 as on their GitHub repo. And that's the demo that I want to show you right now. So let's try to mirror my screen. Yes. So here I have presentation. How does Zoo work? Well, Zoo has a particular. Oops. This one. Okay. Netflix uses a Cassandra file system, their backend, and all of their smart routing configuration is stored in a Git repo. So whenever they want to change the routing rules, they just commit to and push to the Git repo. And since it's on top of a Cassandra file system, the data gets replicated on all of their routers. So it's a very specific use case. So for them to be able to reload the rules dynamically, they created Zoo. And Zoo, basically, if you look at the source code, it's a very simple implementation with basic routing mechanisms. And Zoo does it uses a polling mechanism, so it looks at the file system. You just point to a folder, which in their case, it's a Git repo on the file system. And it's by default, it polls the folder for every 5 seconds. So if they detect that any file has changed, they just reload the routing definitions. So for that, they use Groovy scripts, which is a dynamic language that can be dynamically reloaded. So that's why I'm using here this Zoo file, but it's source compatible with Java, so it's very similar for us. So what did I implement here? I just implemented a basic round-robin strategy. I'm just saying that I can route to a certain host or to another host using Zoo. And for that, just to give you a very brief example, I've deployed some services. Here are all my OpenShift platforms. So I have, oops, Jaeger, pipeline. Okay, maybe I deleted that, but I can deploy. So let's try to pull an image. So I'm going to deploy again. Yanaga /color. I want to deploy a blue pipeline. So give that a name blue. I just created a blue deployment. Okay, I'll create a route for it to be able to be accessible. Let's see if it's working. Blue. I'll deploy another version to be able to route between them. Green. Deploy another one. Also create a route. Green. So green 2. Yeah. So the dumb routing that I was saying that it's layer 3 routing basically, it can be provided by infrastructure. You can configure your own Nginx or HA proxy to be doing that. But if you want to use a feature, for example, from OpenShift, I could be just going to resources. Other no. Routes. I could create, for example, a blue-green route and say that I want to split my traffic between blue and green 50-50. Okay, and I just create that. That's just basic infrastructure routing. And I have here, it's not load balanced because the OpenShift router is sticky. If I want to truly be able to load balance, I need another browser instance. If I'm lucky, it will be, no, of course not. It was random, but it got the, oops. You're kidding me, right? No, this one is green, okay? But it's sticky, so I keep reloading. It will always give me the same one. So one of the advantages of OpenShift, for example, is the router is stateful. It's sticky by default. If you don't want that, you can change the configuration to be playing round robin. So that's a Firefox, and that's what I wanted to show. But if I want to use Zoo, I have these two different deployments here in my backend, blue and green, and I want to be able to perform some smart routing. So now I'll start Zoo. you're not going to run Zoo using Gradle, but it's just a demo, right? In production, you start the Tomcat by itself. So it's running. It's already. Oh, somebody's using. And let me stop my other process, which I believe is this one. Yes. Sorry, too many things happening at the same time. So let's start Zoo again. Now it should be listening. So my implementation is doing the following thing. So it's just round robin between blue and green. Let's see if it works. If I go to localhost 8080, I have blue. If I reload, green, blue, and green, performed by Zoo. So if I just change the file and say that, well, maybe I want all of the requests to go to blue. I just save it. 5 seconds later, at most, Zoo will detect it, and it will always only return blue. Okay, but if I want to deploy another version, let's go here and try to deploy a new one. I'll say I want to deploy a color purple. I'll deploy a purple color. And I say this should be purple. And I create a root for that. Purple. Okay, it's externally accessible. Purple. And I want to perform some kind of smart routing about that. Layer 7, I can add, like, for example, a user agent. In this case, it's just like HTTP header routing. But of course, if I know, if I'm using just business logic in my code, I could get which is the user that is logged in. I could get his or her profile, and I could perform some routing accordingly. I've seen some customers using this kind of routing. For example, you want to release a canary deployment of your environment, and usually you have some customers that are more friendly for some interruptions in the service, if you may say that way. So maybe the routers that are more willing to help you on developing the application, you can always release a new canary for running them, so you can fix before releasing the whole new version to the entire audience. Okay, so you could do that. So I just added here, if that's an iPhone, it's going to the purple one, or else it's going to round robin between the requests. So I just saved the file. It should be routing already on Zoo. So here I have blue, I have green. So, but if I change to an iPhone 10, it shows purple. Okay. So Zoo, it's very simple to work with. It's a very basic implementation if you work on the source code, and that's why it's probably the most popular smart route implementation. And as I said, you can get any metric from your business application. It's just Java code, and you can perform the routing as you wish. Okay. So this was the smart routing approach. But of course, we have some drawbacks. Every time you're using smart routing, you're just assuming you have two separate deployments for each hypothesis, A and B. Some people that are really like mature on this point, they might have even more than two deployments. They might be testing 3 different hypotheses. Even though I think that's a lot of work for the ops team. So maybe you want to avoid that. I've seen that it's very rare to see that people using, but sometimes it happens. Then you always need to be careful with feature branch, which means each branch has its own deployment. And why is that? The reason for performing continuous delivery is we want to reduce the batch size between each one of your releases. But how does feature branch developing works? So basically, I have a trunk, and suppose that I have a team that is working on feature A on this branch, and another team that is working on feature B on this branch. Right? So people, of course, you have all the best practices. Your continuous integration server is every time somebody checks checking in something at the trunk, you automatically propagate the changes to your branches. You're doing that continuously on every single commit, but they are separate branches. So people are committing on these separate branches every single day. And then somebody decided, well, feature branch A, it's good. I've tested that hypothesis into production. I want to merge on trunk. Then they've been developing this feature for like 2 weeks, and they just merged everything at once. Okay, you have a batch size of 2 weeks now. So, well, then the other team is developing feature B. They just decided, well, let's make a pull from the remote repo. You just have a huge merge hell, right? Because they changed a lot of files the past 2 weeks. Of course, you were not integrating because that was an unmonitored feature branch, which you didn't know even if you would make to the trunk. You just got that huge source conflict, source code conflict, and you're screwed. I did that in the past, and in all of the teams that I've talked to, they did the same approach. When you had this huge mess, you just discard everything that you had. You just copy the files that you think are important, and you paste over the new version that came from the trunk, which you might think is not the best approach for developing software. But usually that's the easiest way for you to try to solve this kind of conflict when you have this huge batch size. So feature branching is evil in the sense that the reason for trying to engage in DevOps and applying continuous delivery is to reduce the batch size. If you just decide to do feature branch development and you have like huge time developing in different feature branches, you just got back to starting point, which is I have a huge batch size and I'm making conflicts with everybody else. So I have a huge risk of introducing bugs into production, okay? Because of the batch size. That's something that should be avoidable. So if you prefer to use smart routines and feature branches, the best practice here is that your feature branches should be really small. Really small, like for some companies, small means the same day. For some companies, very small means 1 week. But it really depends on how you're developing software and the pace of your development skills. Okay? So, and again, some companies, instead of using different feature branches and smart routines, prefers to use feature toggles. So feature toggles, some people say some jokes about that, saying that, well, that's just a global if that you can toggle between the different branches of your source code. In practical terms, I think it is, but usually when you're using feature toggles, you have a platform for managing these feature toggles. And the basics about feature toggling is that you want to separate the releases of new features from your software from the deployments, right? You're deploying your software multiple times per day, even while you're developing your feature, which is not yet available to the user. And the classic example of feature toggling is like when Facebook decided to launch their Facebook Messenger. The feature was available for months for users. So every time you went to the Facebook page, Messenger was already available. Messenger was being used in the background of your page, but you didn't know the feature exists because they didn't know if their backend servers would scale well enough to handle all the traffic. So for this case, in some months, they had the backend servers ready. They injected some JavaScript on the page, which was simulating conversations on the backend. So in secret, you were really talking to your friends on the Facebook network with some, I don't know, random stuff, just for Facebook to be able to measure the performance of their backend servers. And they were taking that for months. When they realized, oh, now the performance is good enough, they just went to the interface, enabled the feature toggle, and oh, Messenger is available for everybody. The feature was there. It was just hidden from the users. And that's how basically a feature toggle platform works. You can do that like for releasing a new feature. Well, it was already there, but now we're showing that. That's how you do when for feature toggling in the UI. So people that are developing single-page applications or using JavaScript for that are used to perform this feature toggling. Or when you want to change the color or position of a button, you have feature toggling on the front end. But if you're performing back-end development, usually the feature toggling works when you're trying to change algorithms into production. you do feature toggling on top of that. So that's the demo that I want to show you right now. So let's mirror again. There are many different frameworks for performing feature toggling. Let me quit my Zoom. And also stop my Zoom server here. So let's get back to this demo. So the two most popular feature toggle frameworks in the Java space are FF4J, which is the one I'm showing right now, and ToggleZ. I've been discussing, FF4J was my favorite in the past, but in the past, the last project that I used that deployed this into production was like 2 years ago. So some things changed in the past, so ToggleZ evolved a lot. So at least this year, at least, I've talked to 2 different teams that prefer ToggleZ instead of FF4J. So I don't have a strong opinion. I guess that both are valid right now to be used into production. Okay. Now, how does it work? FF4J, for example, I have a sample Spring Boot application running here, and all of the configuration of FF4J is performed using an XML. Basically, you're just saying, I have a feature called hello. It's enabled by default. I have a description which will be shown on the interface. I have another feature called new recommendation engine, which is not enabled by default. And this state of this my sample application, the state of the feature toggles is in memory. But of course, in production, you want to rely on a persistent store, database, or in-memory grid. You could be using Redis for that, for example, too. And that's the recommended approach, because you don't want to lose the state every time you restart your application. And how does it work? I have in my application, basically, I just declare a new FF4J instance. And here I registered my, my console. And how does it work? Here I have a hello controller, which by default returns checks. No, Cześć. Cześć. I need to train my Polish. So it was hard enough to try to type the S and the C with the accent, okay? Sorry for my, it's hello in Polish. And if you want to toggle between the hypotheses, so if you want to check, it's very simple. You just add an if in your code. If ff4j.check and the feature is hello. If it's enabled, I want to return Polish. Else, I want to return Olá, just because that's Portuguese. Okay, and this one I can say. So we want to run our application. So now if I go to localhost 88/hello, it's showing for me in Polish. But if I go to my control panel, which is basically my FF4J control panel, and if I go to the features, I can see my feature list, which is very big by now. Let me try to reduce that. If I turn off the toggle, you can see that now it's showing in Portuguese. So that's how dynamically you change using ifs. But we can be better than that, because most people complain, well, I don't want to be adding ifs in my source code, which in fact most of the times is a bad practice. So let's get back to my source code, which is here. I'll just quit this Skype because it's just bothering me. Okay. So what can you do? Suppose that I have a recommendation controller, and here I'm using a recommendation controller. And here I'm getting a recommendation engine, which is a bean that I've implemented. So it's being automatically injected by Spring. So let's go, how does it work? If I go here, instead of hello, I can go to recommendations. It's giving me some very bad recommendations for burger, soda, and hot dog. But suppose that I have another algorithm for recommendations for the user, and I want to test that, and I don't want to add an if into my code for performing that. So how can I implement this feature using feature toggles? Well, maybe instead of adding this if, I can use some AOP and just say the FF4J feature, and say that the feature is new recommendation engine. So that FF4J can flip that on runtime. And I can just go to my configuration and say, well, I have a bean of the type default recommendation engine. And now I want to create a new public improved recommendation engine. Return new improved recommendation engine. And that's a bean too. And you know, if you ever use Spring, you know, well, I have two different beans of the same type recommendation engine. If I try to run my application this way, I'll have a conflict because Spring doesn't know which one it should be injected in my controller, because the type here is just recommendation engine. So for this configuration to work, I have to say in my application, I need to say that one of them is the default. So the default one is tagged as primary. So this way my application should be working. And if I just restart here, it will work the same way. And the application started. You see it's returning burger, soda, and hot dog. I can go here to the feature toggle list and turn it on. So let's see what is the new recommendation engine. It just show beer, schnitzel, and pierogi, which is very nice, by the way. Okay, my favorite Polish food so far. It's Polish, right? Okay, I'm not mistaken. Thank you. So this is basically how you use with feature toggling. But of course, feature toggling has its own disadvantages. We don't have a win-win situation here regarding feature toggling too. Like feature branches is evil if you don't use it the proper way. Feature toggling too. One of the complaints is that if you're using the if statements on your code, it's very easy for you. Oh, we turned feature A into production. It's working properly, just leave it there forever. So nobody deletes the if. And the legacy code still keeps on the source code base, even though it's not being used anymore for years. You know why you should delete if it's working? Yeah? You don't touch it. But the other problem is that I was talking to at least 3 different teams that had this issue. They were a huge development team. They were using microservices too. They had all feature toggling. And then each team was performing feature toggling in the system for each microservice. But then for some months, people were using and monitoring the metrics, the business metrics. And then somebody just realized it. I don't think that makes sense, the metrics that we're doing, because I think that this feature should be performing better than the other one, but it's not the case. And there are some days of the week that we turn it on, and it's better. And some days of the week that we turn it off, and it's good too. So what has happened? They just realized that, well, maybe we're doing it wrong. So they got a huge meeting between all of the development teams, and they just realized, oh, everybody's performing feature toggling. But nobody's coordinating which feature togglers are enabled at a certain time of the day. So basically, the feature togglings were random. It's because I was testing this hypothesis, but the other team was also testing some other hypothesis, but their feature was messing with my feature. And they didn't know when that was being used or not. So they had this huge conflict because on one of the teams, they just realized that at a certain time of the day, all of the teams, they had like 40 feature toggles in their code. So you had like a huge mess. It's an infinite amount of possibilities of the toggle states to the 40. So they had to create, which is kind of counterproductive if you think about microservices. They had to create a feature toggle committee. Okay? So they had a committee from one person from each team. And this committee would decide, oh, today we are going to test these toggles. So only these toggles are on, and you monitor. Okay? So, and then they need to create a schedule. So the committee was organizing which toggles would be on these days, and for how long they would be monitored, which I know it doesn't make that much sense. But it happens. If many people are testing different hypotheses, and all of them impact in the business, you get different metrics. So it was one of the solutions. I didn't find a better solution yet, but these teams that struggled with feature toggles, they solved this problem this way, with feature toggle committee. Not fun, probably. Yeah? Then you need another committee to be solving this kind of thing. And the last tool that I want to show you how to perform this kind of thing is a service mesh, which is, of course, is new. We just had an Istio workshop this morning at the Room B, talking to some developers. So what is a service mesh? Think of service mesh basically as AOP for infrastructure. There are some concerns if you have a distributed architecture. Usually there are some concerns that need to be cross-cutting to all microservices, like all microservices need tracing, all microservices need logging, all microservices need circuit breaking, and everything else. And the history is that the evolution of technology works this way. Usually when you face a problem, nobody has solved that before, you can't find a solution in the market, you have to solve that by yourself. That's what Netflix did in 2004, when they were trying to migrate their monolithic architecture to a microservice architecture. They had no solution for that, we need to solve it by ourselves. Then they realized, oh, maybe after 1 year or two, we have some best practices on how to solve this problem. Then luckily for us, they decided to open source the libraries. So the next step in the solution is I do it by myself. I consolidated some solutions. They are best practices. I want to share the solutions between multiple teams. And luckily, they decided to share with us too. So they released Netflix OSS as libraries. The problem with that is that it's only available to JVM languages. But if you think about the evolution of software too, first step, do it by yourself. Second step, you share that through libraries. Third step, you try to push that to a lower layer, which means that you usually try to push that to infrastructure because you don't want to worry about that anymore. Remember in the past when we had like transaction management, it needed to be on the code. Then we created transaction managers, which could be handled by infrastructure. We just had to say transaction start, commit or rollback. So we have a layer in infrastructure that is dealing with this cross-cutting concern. And luckily for us, in 2018, I don't have to worry anymore about service discovery, load balancing, tracing, monitoring, circuit breaking. I don't need to use the Netflix OSS stack in my code. I can use infrastructure to do that for me. And Istio is the solution that usually Istio, people that are using Istio usually use that on top of Kubernetes, so you can have the whole set of features to deal with. So Kubernetes deals with service discovery, load balancing, and other stuff. And Istio, you can use Istio for circuit breaking and tracing and everything else. Okay, and this is the basic architecture of Istio. Istio has 3 different components. You have Pilot, which is responsible for the configuration and most of the routing between each one of your microservices. You have Mixer, which is responsible for collecting the statistics, how many requests per second, and rate limiting, and some kind of routines. For example, you can inject fault in a microservice network. You can rate limit. I want this endpoint to receive at most 10 requests per second. So this kind of statistics is controlled by Mixer. And Istio Auth deals with security. So if you want mutual teleasset authentication between your endpoints, because that's a good practice. If you have a huge organization, you don't want or you shouldn't be trusting every one of your teams, because somebody might inject a faulty service in your network, you don't even know that. So you want to perform some trusted certification. That's the responsibility of Istio Auth. And this is the Istio architecture. And for that to work, basically, the default implementation of Istio uses a sidecar container on top of Kubernetes. So every time you have a container running on Kubernetes, Istio creates a sidecar containers that runs side by side. And the Envoy sidecar basically proxies all of the incoming and outgoing traffic from your application. This way, the Envoy proxy can add the features that you want, like tracing, circuit breaking, fault injection, and all this kind of stuff. Yeah, and also gathers the statistics and everything else. Envoy, for now, can proxy HTTP traffic and can also proxy gRPC traffic. And we have some people working on a connector for AMQ2, so you'll be able to proxy all of your ActiveMQ connections, because that's a requirement for some customers. And how does it work, and why is that useful? Because you have another very advanced scenario for testing your hypothesis, which is mirroring. And basically, it's a hypothesis for performance. Who uses that? Twitter, for example. Twitter, before deploying any new version into production, they just create a new separate backend, and they mirror the production traffic. They put a routing in front of that. All of the production requests go to the production servers, but they mirror the request to the new deployments to test if the new backend will be able to perform correctly. And they also can test if the results of these new deployments are correct, comparing the results from the production requests. Okay? So how can you apply mirroring? Today, the easiest way, I don't know if you ever did mirroring in backend infrastructure. It's very complicated to perform that manually. But luckily for us, 2018, Istio has mirror built in as one of their features. So how does it work? I have a cluster here deployed on my Kubernetes cluster, and it's running Istio. So what do I do here? So I'll be performing a curl on my backend. I have 3 different microservices: customer calls preference, preference calls recommendation, and I have 2 different versions of my application running into production. You see there's a round-robin routing between version 1 and version 2. You can tell by the counters. Each one of them is getting one of the single requests. But that's just the traditional routing. I have one version, one application, 2 different versions, and I'm round-robin between them. I could use Istio to perform a canary, to root. I could use OpenShift and Kubernetes to do that too. But the thing that I want to show is particularly the mirroring. So what I'm trying to get here, I'm trying to get the logs from version 2. Like here on the top, I'm just tailing the logs of version 2. You can tell that. And I'm going to tell Istio that while it's still running, I want Istio to apply, create a rule for mirroring everything from version 1 to version 2. So version 2 will be out of the production, and all of the requests will be mirrored. How does it work? The request to version 1 will be synchronous, and the reply from version 1 will go to the client on production. Version 2 is fired asynchronously. So Istio uses Envoy to basically duplicate the request, fire to the other backend, and forget. Okay, so Istio doesn't care about the results. We need another tool to be comparing the results, which I'll show you later. And right now, I just applied this route from Istio, mirror traffic from version 1 to version 2. And if I go to the logs right now, you see that production requests only gets the replies from version 1. But here on the logs, version 2 is still receiving the same requests. So that's why I can see the logs. If you don't trust me, here are the requests from, this means version 2. Okay? So I have mirrored requests. If I just go to Istio and delete the rule, then everything goes back to round-robin strategy. You saw a 503 error. Yeah, that's because of Istio. I'm using an old Istio version. I didn't have time to update to the latest one, but it seems that they fixed that into the latest version, okay? Because 08, which is the current version, aims to be production ready. So let me try to show. So that's mirroring, and people say, well, you want to perform mirroring, but if you have 2 separate deployments running into production, and production request goes to these and these, both are connected to the same production database. What about my data? Do I get duplicate results for everything? So the answer is not that simple. I try to answer some of these questions into my book, which I released last year. But of course, mirroring is kind of new. So if you want to know how can you create like secure S architectures and everything else, you can read my book, which is available on this URL. Or if you go to my Twitter, it has a URL to the book too. But basically, when we're talking about data and mirroring, means that I have two different production databases. And the best answer that I found so far, that one team at least was using this, is that both versions goes to the same production database, but version 2 adds a virtualization layer. And on top of that, I have a Diffy database, which has the same schema as the production database, but this Diffy database only stores the updates, the inserts, and deletes that are different from the ones that go to production. But when you query your database, you get a merge from the production and Diffy database on the production servers, so you can test the results of your both services. Yeah? How did I do that in the past, and which was the most common approach for dealing with mirroring? I have requests, I mirror on both, but the new version goes to a copy of the production database, which in my particular case, to perform a copy of the database to test a new service, it took me 12 hours to be able to get a replica, which was a pain in the ass to be asking the DBA to do so. So he didn't have like goodwill to be doing that for me. But since it takes too long to be creating this replica, usually you run the test for a long time. But if you run that for a whole day, and then if you have different algorithms, by the end of the day, when you want to compare the results, the data sets are so different that it's not meaningful anymore. Okay, so that's why virtualization helps a lot. You can go at the Diffy database and you really compare just the records that are really different from the production database. Okay, so that's a very useful way of trying to compare the data that is running behind each one of your services. What about my other services? Well, sometimes you want to mirror, and it's not just about the database. Maybe your new microservice is calling other endpoints too, but you don't want to disrupt the other endpoints. How do you do? Then maybe the answer for that, you need to use service virtualization, which is an ancient technique you created on the SOA times, like the 90s. And I think that service virtualization is a bad name because basically it serves mocking. You just create mocks for your service. So maybe I proposed it to some guys, maybe you should change the name. And the answer was that I read the books from the 90s from service virtualization, and this term has been used since then. So in the past 20 years, service virtualization was the term for service mocking. People just didn't use that. But now that we have microservices, and now that we have tools to make mirroring easy, people are getting back to used to the term. Okay? And last thing that I wanted to tell, there is a new tool, again from Twitter, called Diffy. Diffy is a tool that, if you have mirrored services, allows you, Diffy gets the mirror request that goes to your backend and records both the production request and the mirror request. So every time you get that, Diffy records that and it stores a diff of both the replies. So you can go to the interface and compare how the results are different from version 1 to version 2. And of course, you can say, well, if my reply gets a timestamp, it's obvious that all of the replies will be different. But Diffy is smart enough to know which fields on your reply always change. So you can mark that, oh, this is a timestamp. This always changes between one and the other version. So you can mark, ignore this part, and just show me the real difference between one and the other results. Okay? And all of this content will be available at developers.redhat.com. If you want to reach out to me, my Twitter is @Yanaga, which probably is the easiest way to talk to me. But my email is also yanaga@redhat.com. Please feel welcome. And that's what I wanted to say, and thank you very much. Thank you.